Hello dear students, this is your engineering mathematics 3 lecture. Today's topic is solution of system of non-linear equations, or the solution for the algebraic transcendental equations using numerical methods. That the first numerical method is Regula falsi method. This method is used to solve the transcendental equations, or to find the solution of nonlinear equations. See, what is the Regula falsi method? Let f of x is equal to 0 be the given equation. In this method, we choose 2 points, say x0 and x1, such that f of x0 and f of x1 are of opposite signs. Opposite the function values for the 2 points x0 and x2, they are opposite signs. We choose such a 2 numbers x0 and x1. Since the graph of y is equal to f of x crosses the x-axis between these 2 points, a root must lie in between these points. The equation of the chord joining the 2 points x comma f of x comma x0 comma y0, f of x0 means y0, and x1 comma y1 means f of x1, and it is given by the equation 1. Taking the point of intersection of chord with x-axis as an approximation to the root, the point of intersection in the present case is given by putting y is equal to 0 in equation 1, and then we get the Regula falsi. We get the formula of Regula falsi, and that formula is nothing but x is equal to x0 minus f of x0 upon f of x1 minus f of x0 in bracket x1 minus x0. Here, that is the first of approximation. This equation number 2. It is the formula of Regula falsi method, and it is the formula of first approximation. And from the first approximation, you will get the second approximation to the root of the equation f of x is equal to 0. It is given by x2 is equal to x1 minus f of x1 upon f of x2 minus f of x1 bracket x2 minus x1. Thus, f of x2 and f of x1 are of opposite signs, hence the root lies between x1 and x2, and we replace x2 and x3 in equation 3 and obtain next approximation. The procedure is repeated till root is till the root is obtained to the desired accuracy. Okay, so that process we repeat till root is obtained to the desired accuracy. Now see the example here. The first example: obtain the root for each of the following equations correct to the 3 decimal places using Regula falsi method. Now there are 4 equations. We are going to find the root of the first equation. We are going to discuss the first one. That equation is x cube minus 4x minus 9 is equal to 0. Now write down f of x is equal to x cube minus 4x minus 9. Okay, this is your function. Now here we are going to choose 2 points whose function values have opposite signs. Here we have mentioned in while discussing the method, Regula falsi method. In this method, we choose 2 points, say x0 and x1, such that f of x0 and f of x1 are of opposite signs. So how to choose these 2 points, 2 points x0 and x2 have the function values of opposite sign. Here in this function, we're going to find the root of this function, root of this equation. In this function, you put x is equal to 0. You start from 0, 1, 2, 3. If you are getting all the function values positive, then in that case you can put x is equal to -1, -2, -3 also. So here that equation have some positive terms and some negative terms. X cube minus 2x minus 5. So you start from 0, put x is equal to 0. So if we put x is equal to 0 in the equation, the value of the equation is -5. So the function value is negative when x is 0. Then put x is equal to 1, then the function value is -6. If we put x is equal to 1 in this equation, then the function value is -6. Still it is negative. Then put x is equal to 2. We put x is equal to 2 and solve this equation, then the value is here -1, still it is negative. So you put x is equal to 3. If we put x is equal to 3 in this equation, the value is here 16, which is positive. So f of 2 is -1 and f of 3 is equal to 16, means f of 2 and f of 3 have opposite signs. Therefore, the root of the equation lies between 2 and 3. Here, the real root of the given equation lies between 2 and 3. So these are the 2 points x0 and x1 here. Sorry, discussing this example here. X cube minus 4x minus 9 is equal to 0. Here you put x is equal to 0, 1, 2, 3, 4. If you put x is equal to 0, the function value is -9. Then put x is equal to 1, then the function value is -12, still it is negative. Then put x is equal to 2, then the function value is here -9. It is again negative, so put x is equal to 3. So if we put x is equal to 3 in this equation, the function value is here +6, which is positive. So the root of the equation lies between 2 and 3. We are discussing about this equation, x cube minus 4x minus 9 is equal to 0. We're going to find the root of this equation using Regula falsi method. So f of 2 and f of 3 have opposite signs. So root lies between 2 and 3 here. Okay. Now, what is the formula of Regula falsi method? Here it is x is equal to x0 minus f of x0 upon f of x1 minus f of x0 in bracket x1 minus x0. Now here your x0 is 2 and your x1 is 3. Okay, because root lies between 2 and 3. So x0 is 2 and x3, sorry, x1 is 3. So put here the values. X0 is equal to 2 minus f of x0. Now what is x0? 2. So what is the value of f of 2? Which we have calculated here. It is equal to, see, what is f of 2? Its value is -9. So put here the value -9. So minus sign is already there, so minus minus plus 9 upon f of x1. Here x1 is 3. So f of 3 is 6. I calculated it 3. Sorry, f of 3 is 6 plus f of x0 is -9. So minus minus plus, so the term is 6 plus 9. In bracket x1 minus x0 means 2, 3 minus 2. Okay. So simplify the term, and if you calculated the value of x1 is there 2.6. Okay. Now we find the function value of f of 2.6. We find the value of f of 2.6. This is the equation, given equation for which we are going to find the roots. In this equation, you put x is equal to 2.6, put x is equal to 2.6 and simplify it. Then f of 2.6 is -1.824, and this f of 2.6 is -1.824. This function value is again negative. F of 3 is equal to 6, which is positive. So the root lies between 2.6 and 3. F of 2.6, its function value is negative, and f of 3 function value is 6. So now the root lies between 2.6 and 3. So using the equation 1, means using the again Regula falsi method, the x0 is 2.6 and your x1 is 3. So put x0 is equal to 2.6 in equation number 1, which is here. This is equation number 1. In this equation now x0 is 2.6 and x1 is 3. So put the values here in this equation, put in 1, so that you will get the terms 2.6 plus 1.824 upon 6 plus 1.824 in bracket 3 minus 2.6. And if we simplified it, the value of x2 is 2.6932. Okay, this is your next value of x, 2.6. The base one was 2.6, now it is 2.6932. Now you find the function value of 2.6932. Means put in f of x is equal to 2.6932, and you simplify the function after putting the value of x. It is equal to -0.2382. So it is -0.2382. The function value is negative. So the root lies between 2.6932 and 3, because f of 3 is equal to 6, which is positive value. Function value is positive, and for f of 2.6932 it is negative. So root lies between 2.6932 and 3. Now using again equation 1, again use regular falsi method. Using equation 1, here x naught is 2.6932 and your x1 is 3. You put here the values of x naught, x1, f of x naught and f of x1 here. Simplify it, and their f of x3 is 2.704. So this is your value of x now. Now you find a function value of f of 2.705. To find f of 2.705, if we put the value in the function value is here minus 0.045, which is negative. Function value is negative, and f of 3 is equal to 6, which is positive. So the root lies between 2.705 and 3. So root lies between 2.704 and 3. So using equation 1, here x4 is equal to, now put in equation 1. Now your x naught is 2.704 and x1 is 3. So put in equation 1. After putting in equation 1, x4 is equal to 2.704. So this is the value of x here. The root of the equation is 2.704. Now you find a function value for 2.706. We put in function f of x, the x is equal to 2.706. Then the function value is again negative. So f of 3, its function value is 6, which is positive. So root lies between again 2.706 and 3. So using equation 1, again using regular falsi method, you find the next approximation and put again x naught is equal to 2.706 and x1 is equal to 3. Simplify it, and then your answer is x5 is 2.706. So x4 is 2.706 and x5 is also 2.706, means it is correct up to 3 decimal places. So this is the root of the given equation, which is correct up to 3 decimal places. So this is our answer using regular falsi method. So this is regular falsi, or this is also called false position method. Here we first find 2 points x0 and x2 where f of x0 and f of x1 have opposite signs, and then we find the root of the equation using regular falsi method. So this method is over here. You can try or solve the remaining equations. You can find the roots of the remaining equations using regular falsi method. You just do the practice. Now this session is over here. The method regular falsi method is over here. This session is over here. Thank you.